Good afternoon, everyone. We have a video here to go along with the problem I just put out on density of silicon. So this relates to general chemistry 2, and when they talk about unit cells and the crystalline structure of, typically they're either molecular or ionic solids. And the information they give us is the edge length, or you can say maybe the side length of your cube. In this case, we're dealing with silicon here. And they say it crystallizes into a diamond cubic lattice, which is what you've been dealing with here in this particular section. And they have 543 picometers given. That's very, very tiny. Remember, a picometer is 10 to the negative 12 meters. Then they give us that we have 8 silicon atoms per unit cell. Now, if you recall, there was a chart I put out about a week ago that indicates how many atoms are in a unit cell. And I don't recall the numbers exactly. This particular structure is not in the ones you should probably know, but it's out there. And of course, they give you the information so you don't have to look it up or memorize it. I'll also include a link to the video in this document once it goes out onto my website. Some things to consider are, here we have the atomic mass of silicon, we'll need that. And we need to know, of course, Avogadro's number, that's number of particles or atoms per mole. And then we know that volume of a cube is simply its side length cubed. And then we have that length as being 543 picometers. And then last but not least, of course, we need to know that density. And in reference to this problem, we're dealing with, we'll calculate the mass of a unit cell, given our information on our atoms, and then we'll calculate the volume of our unit cell, given the side length. So we'll need to do some calculations on both the numerator and denominator, and then put them together, divide top by the bottom, we'll get a density for silicon here, okay? So I'm gonna go ahead and scroll down here. And I do give the answer. I should probably block that off. I have, yes, density is mass over unit volume. So once we get these calculations, we'll feed it into our division problem and of course get about 2.32 or 2.33 grams per centimeters cube. Let's deal with the top first. We need to find the mass of our unit cell. And we are given the fact that we have 8 atoms per unit cell. And then we also know that for every 1 mole of silicon, we have 28 grams. And of course, we can use our knowledge of Avogadro's number per 1 mole of substance. We can figure out how much mass does one atom have, and then just multiply by 8. So I'll go ahead and put that out there for you. We know that we have we'll start off with this. And we know 1 mole of anything, right? And we're dealing with silicon here, right? So atoms, silicon. Okay. And last but not least, if we stop here, we'll just figure out how many grams per 1 atom of silicon. So actually, I will back it up here. I will back it up here, and we'll start there. So if we cross out our units, we should have, and I did run the numbers, I'll run them again just to be sure. I'm dividing out 28.09 divided by Avogadro's number. I get approximately 4.66 times 10 to the negative 23. And that would be grams per 1 atom. Okay. And because I'm running out of room, I'll just go ahead and go down here again. Okay, so 1 atom has a mass of 4.66 times 10 to the negative 23 grams. And again, this is silicon here. Okay, so I know we have a total of 8 atoms, right? So those 8 atoms collectively, and I could put down here per, per unit cell. All right. So if I just take that resulting number and times it by 8, what do we get? We get, and don't try to erase here. Okay. 3.73 times 10 to the negative 22. And that's atoms per unit cell, right? And where do we need to go from here? I have so many atoms per unit cell. Oh, no, of course, it's not atoms, it's grams. Yes, I have the right math here. I just need grams. Grams of silicon per unit cell. Woo, okay. Yes, because we do have, and I apologize here. Yes, we do have grams per unit cell. Okay. Whew, thought I made a mistake there. Okay. So on the numerator here, and it looks like it might be a little bit larger than what I had calculated before. We have 3.73 times 10 to the negative 22 grams of silicon. And so we're done with the top, right? We know what mass we're dealing with per unit cell. We just need to find our volume, okay? And the only thing we really need to be concerned about is our units. So notice they gave us in the question, we're given, okay, we have what, 543 picometers, right? 543 picometers. And I'm just going to go ahead and put that back into meters. And so that would be 1 picometer is actually, it's 6 one way, half dozen the other. But I'll go ahead and say that 1 meter has 1 times 10 to the negative 12. Right, positive. Okay. Okay, so I know 1 large meter has 10 to the 12 picometers. I also could say 1 picometer is 10 to the negative 12 meters, but I prefer to use positive exponents. Really doesn't matter. Okay. And in essence, I'll get, if I just stop here, if I take 543 and divide out by 10 to the 12th, I'll have 5.43. Okay. But I need this in centimeters. I know 1 meter has 100 smaller centimeters. So times it by 100, I'll have the right units here. Okay. So 5.43 times 10 to the negative 8. All right. So ultimately, that's our side length. And we know volume, I mentioned before, that's just our length times width times height, but they're all the same. It's a cube. So we end up with this number here cubed. Just take that resulting number and cubed it of 1.601 times 10 to the negative 22. That's centimeters cubed. Now, ultimately, and I'll just go ahead and go up here and highlight this answer right here. We have the approximately 3.7 times 10 to the negative 22 grams per unit cell. And we know each unit cell has a volume of approximately 1.6 times 10 to the negative 22. Luckily, we have, you can look at it this way. I'm just going to scroll down a little bit more and write those numbers out. So again, we're taking, and it is duly noted here that my numbers are slightly off. I think I rounded. I think I used a mass of just 28 grams, and that's why the numbers are slightly different. So, luckily here, these two units just cancel each other out. Like both numerator and denominator have 10 to the negative 22. So essentially you're just dividing 3.73 or roughly 3.7 and dividing out by 1.6. And yeah, this answer gets me closer. If you round, it's 2.33 grams per centimeters cubed. And if you actually do a search on silicons, density, you should get roughly that number at room temperature. So that's your final answer. And just to recap here, we needed to get given some data on how the crystal lattice structure is set up in this particular problem, and I'll scroll up again here to the top where the problem is listed here. We're just giving a side length with an edge length in picometers. We know how many atoms occupy that unit cell, and we can pull information from the periodic table and what we know about Avogadro's number and how we can determine volume. Just do some extra math there and put together the numerator and denominator of density and divide it out. And there you go. So thanks again for watching. Hit like and subscribe if you'd like more, or if you'd like notifications on when more content comes out on my channel. Thanks again.